Good morning, friends. Today we are going to see the next point from this topic, that is the surface tension. So today we will see the definition of the surface tension. So what is the meaning of the surface tension? So in the introductory part, we have seen that the liquid will exert the one kind of tension on its surface so that the spiders are able to walk on the surface of liquid, and that property is the surface tension. But theoretically, what is the meaning of the surface tension? That definition we are going to see. So friends, in the examination when the definition is asked, what is the surface tension, then the definition which I am going to tell you, that you have read in the examination. And before this, we have explained in the introductory part, that is in order to understand that concept. But technically, today the definition which I am going to tell you, that you have to write. Friends, what is the surface tension? The surface tension can be defined as the force per unit length acting at right angle on the imaginary side of liquid on the both sides. So the tangential force per unit length acting at right angle on the both side of liquid is known as surface tension. So its mathematical formula is T is equals to F upon L, where T is equals to surface tension, F is equals to force, and L is equals to length. So in order to understand this, we can consider one beaker, and that beaker is completely filled with the water. Okay. So when it is completely filled with the water, and the surface tension is acting here tangentially, and if again I am going to draw one diagram here. So this is a same part. Here the force will be acting on the both sides. It is acting on the left side as well as on the right side. So we have to say that the force is acting on the both the side of the liquid. So what is the surface tension? Again I am going to explain this part. The surface tension can be defined as the force per unit length acting at right angle on the imaginary lines drawn on the both the side of liquid is known as surface tension. Its mathematical formula is P is equal to F upon L. What would this SI unit? Its SI unit is Newton per meter. What would be CGS units? Its CGS unit is dyne per centimeter. Now, if you want to write the dimensions, then look at this formula: force per unit length. What are the dimensions for the force? 1 in mass, 1 in length, and minus 2 in time divided by the length. So 1 in mass, 0 in length, and minus 2 in time. So these are the dimensions for surface tension. So during the board examination, the question will be asked there: define surface tension with SI units and dimension. Then we have tried. The surface tension can be defined as the force per unit length acting at right angle on the imaginary side of liquid on the both sides is known as surface tension. So its mathematical formula is T is equal to F upon L. Its SI unit is a Newton per meter. Its CGS unit is a dyne per centimeter, and its dimensions are 1 in mass, 0 in length, and minus 2 in time. So the next part of this topic is the definition of the surface energy. So again we go towards this beaker. Suppose in this beaker there is a molecule A will be placed inside the liquid molecule. So in previous lecture we have seen that the total cohesive force is acting on the liquid molecule. If we want to bring the liquid molecule above the surface of liquid, then some amount of work has to be done, and this work is stored in the form of energy, and that is known as the surface energy. So what is the surface energy? The surface energy can be defined as the amount of work has to be done to bring the liquid molecule above the surface of liquid is known as surface energy. As it is the energy, so what will be SI unit? Its SI unit is joule. The SI unit of surface energy is joule. And what will be CGS unit? Its CGS unit will be erg. And what will be its dimensions? Its dimensions are 1 in mass, 2 in length, and -2 in time. So the question may be asked that define surface energy with its SI and the dimension. So how we have to define? The amount of work has to be done to bring the liquid molecule above the surface of water can be stored in the form of energy, and that energy is known as surface energy. The SI unit of surface energy is a joule, its CGS unit is erg, and its dimensions are 1 in mass, 2 in length, and -2 in time. Friends, the next part from this topic is the relation between surface tension and surface energy. So this question will be asked in the examination for 3 marks. Obtain the relation between surface tension and surface energy. Now, in order to get this equation, first we should draw a diagram. So let us consider one rectangular frame P, Q, here P dash, Q dash. This is one rectangular frame. Here you can observe that it will be open from one side. Now we should add one thin part RS having the length L. L will be the length of this rod. So this rod will be added here. So here we can observe that one short frame PQSR will be formed. Now this frame we have to dip in the soap solution. When we dip on the soap solution, then the soap will be stuck here, and then we should add the force so that it will be got displaced here R dash S dash. So the displacement dx and the force will be acted here. Suppose this is F and this is F dash. Normally the liquid have the tendency to contract. As the liquid will be contract, the phenomenon of the surface tension will be developed, and in order to stretch we should apply the force, and that force will be suppose F dash. So here both the forces F and F dash are equal. Again I am going to explain this part. So let us consider PQRS be a rectangular frame which is dipped in the soap solution. Then we should apply the force so that it will be got displacement through the displacement dx. Remember here I have written the small displacement dx, and F will be the force which is acting on the frame. Now F and F dash both are equal in magnitude and opposite in direction. According to the definition of the surface tension, T is equal to F upon L force per unit length. Here, as it is rectangular surface, it has the two surfaces in contact with air. So in the place of L, we should take the 2L. Here again I am making surface tension T is equal to F upon 2L. So this is according to the definition. You should write the definition. According to the definition, surface tension T is equal to F upon L. But the liquid has, here you have to write the sentence, but the rectangular frame has two surfaces in contact with the air. That statement you have to write. So T is equal to F upon 2F. That statement is necessary. Now we can write the force as F is equal to T into 2F. This is the equation number 1. So this is the force. Now the work have the formula work is equal to force into the displacement. So let us consider dw with small amount of work done, f with the force, and dx with the displacement. Here we have seen. So this is equation number 2. From equation 1 and 2, substitute the value here. So dw is equals to, what is the value of f? T into 2l into dx. L into dx is length into breadth, that is nothing but the area. So dw is equals to T multiplied by dA. So 2l into dx will be got replaced with the dA. So we can write T is equals to dw by dA. So surface tension is equals to work done per unit area. But this work done is stored in the form of energy, and that energy is known as the surface energy. I am using the S dot E, that is the surface energy. So T is equals to surface energy upon dA. So SE is surface energy is equals to T into dA. So surface tension into the area. So this is the relation between the surface tension and surface energy. Friends, I am going to explain this part once again. Remember, this question may be asked in the examination for the 3 marks. Obtain the relation between surface tension and the surface energy. Then we should draw this diagram. After drawing the diagram, we have to write that. Let us consider PQRS be a rectangular plane which is dipped in the soap solution, having the length of RS is equal to L. When the force F is acting on the side RS, then equal amount of force will be exerted on the opposite side, so that it will be got displaced through the ds. Or in simple word, we can write that if the force F dash is applied on the side RS, then it will be got displaced through the distance dx. According to the definition of the surface tension, T is equals to F upon L. Surface tension is equals to force per unit length. But there are the two surfaces in contact with the air for the rectangular plane. So T is equals to F upon 2L. Now F is equals to T into 2L. Right. So we have written the equation for the force. Then according to the definition of work is equals to force into the displacement. So F into dx. So what is the value of F? T into 2L into dx. 2L into dx into breadth is nothing but the area. So dw is equals to T into dA. Therefore T is equals to dw by dA. So surface tension is equals to work done per area. But this work done is stored in the format of the surface energy. So T is equals to surface energy upon dA. Therefore surface energy is equals to T into dA, where T is the surface tension. So what is the relation between the surface tension and the surface energy? Surface energy is equal to surface tension multiplied by the dA, that is the surface area. So today we have seen what is the surface tension, what is the surface energy, and the relation between surface tension and surface energy. So I hope you have understood this point. Try to make the note properly. Thank you. Have a nice day.